Hi, this is Kanan Irons here with Markforged Systems, and today we're super excited to share with you a new product announcement from Markforged. Markforged Simulation is finally here. Strength analysis capability has been an ask from us and our customer base of engineers and designers for a long time, and Markforged has answered the call and delivered a great product that we can't wait to show you. Joining me today is fellow 3D printing application engineer Jesse Hayworth, who's going to give us the scoop on this exciting new software capability. Hey Jesse, so just how big of a deal is Markforged Simulation, and what does it mean for those who currently use Markforged 3D printers?
Hey, thanks for the introduction, Kanan. And just like you, I'm really excited to be here because Markforged finally has an answer to that question of how do I validate my 3D printed parts? So FEA isn't exactly a new thing. It's a huge part of the product development cycle. But with 3D printed parts, you have things like different layer heights or different infill geometries. And with Markforged parts, you even have the option of creating composites with continuous strands of continuous fibers. So with any one of those, it's going to be very difficult to create an accurate simulation of the part. So what essentially Markforged users have done in the past is print a part, test it, and find that maybe it's not strong enough, so it needs some additional material, or maybe it's too strong for its intended application, so it's just using excess material. So now with Markforged Simulation, you have a tool that will tell you before a part is even printed whether or not it's strong enough, and more importantly, it's going to give you options for adjusting print settings to meet your specific part requirements. Like you said, Kanan, I don't think I can stress enough how useful this software is and just how awesome its capabilities are.
That is pretty awesome. We can now predict how strong printed parts are, and not only that, but the software will also make changes to the part slice settings to make it strong enough for our intended applications. That's cool. I don't think I've seen that before anywhere else. And I know a few customers in particular who are going to be pumped for this new capability. So Jesse, can you tell us more details about how this software works, who will it be offered to, and maybe something about how our viewers can get their hands on it?
Yeah, absolutely. So at the moment, Markforged Simulation is a linear elastic solver, which essentially means it's going to predict how a 3D printed part will perform up until the point that it breaks, yields, or fails in some other way. And right now it works with both Onyx only parts and Onyx plus carbon fiber reinforcement. And what that means is users that have any of the Markforged plastic printers are going to be able to take advantage of simulation in one form or another. And this one's going to be a fun statement that I probably won't get to make very often in my career, but as of the posting of this video on our YouTube channel, Markforged Simulation is live, and users can take advantage of it right now as part of a free trial that Markforged is going to run through April of 2023. So users have plenty of time to take advantage of it and simulate their parts.
Hey, you gotta love those free trials. So how can users access the actual simulation tool? Does it work with the current Eiger software, or is it a separate download?
Yep, so since the Eiger slicer is all online, there's no need for software installs or any sort of updates. Simulation will work with all accounts, and it doesn't even matter how long you've had your account for. To actually have it added to your account, you can use a free trial link within the software itself, or we also have a link down in the description of our video that you can click on to have it added. And again, the tool is going live today, so once you have it on your account, you can start simulating your parts.
So we do happen to have access to Markforged Simulation right now, and we've been testing it out. And so Jesse, could you give us a demo of the simulation software so our viewers can see how it works?
Absolutely. Let's go ahead and jump right on into it so we can start showing how simulation works. So to get us going, I've already uploaded a end of arm gripper part and have it fully sliced. So as you can see in the lower right hand corner, it's fully ready to print. But rather than printing it, we're going to access simulation by clicking on the associated button. And this is going to take us to the simulation configuration tool. So setting up conditions to run a simulation is actually really easy. All you need to do is set up at least one anchor to represent where the part is going to be remaining stable, and at least one load to show where the force against the part is going to be coming from. So for this particular part, I'm going to set up some anchors on these bolt holes here, and that's going to be representing where the part is going to be held in place while it's actually in use. And then I'm going to put the primary load surface against this one right here. And this is actually really cool because it's really easy to change the direction where the load is going to be coming from against a face. So I can use this widget right here to change the different locations of where it's coming from. You can be a little more accurate with the exact angles down below here in these boxes. And then if I want to simply flip the direction that the load is coming from by 180 degrees, I can just click on this blue arrowhead, and now I have the direction that our force is coming from correct. And then what you can do as well is you can set the amount of force that's coming against that face here. So I'm going to set this to 150 newtons, and then once we have this in place, our part is all ready to be simulated.
Okay, so I see that anchors and loads have been applied, and that workflow looks very similar to what you would see on something like SolidWorks FEA analysis software, pretty simple. And so can you tell us more about the variables of factor of safety and deflection?
Yeah, definitely. So we'll start with the first one you mentioned there with factor of safety. And in the context of the Markforged Simulation tool, this is going to be a multiplicative figure of how much load you want your part to withstand. So this is essentially, like it says, is going to be a safety buffer. For example, I have my expected load against our primary face to be 150 newtons, but the part might withstand more than that at some point during its life cycle. So with a safety factor of 2, that's going to set up the part to be generated and expected to withstand up to 300 newtons of force. And then max deflection is going to be pretty straightforward as well. This will simply be the maximum distance that we want our part to move or potentially deform while it's under load. So in general, this is going to be a low figure for stiff parts like that 2 millimeters that we have set now.
Okay, cool. So what is the next step after you've defined all your loading conditions?
Yeah, so now we have our conditions in place. What we do is save our load case and then validate the part in the lower right-hand corner. And basically what that's going to do is take the current print settings that we have now and check whether or not they are going to meet the conditions we just set up. The validation doesn't usually take that much time, but what we're going to do is a little TV magic and jump to the end results. And we can see that some areas of the part don't exactly meet the standards that we want. Though it doesn't really matter what results we get here, because now we have the option to run a simulation study with that optimize button down in the lower right. And that's going to see if there's a better way to print the part. So even if the settings that we have right now passed all of our expectations, essentially there might be a better way to print it. So we'll do a little bit more TV magic and then jump to the end simulation results here.
So it looks like we have an overlay showing displacement with an expected amount of deflection, and it also shows an updated safety factor.
Yes, exactly right. So after the simulation study, we get to see again how our current print would perform. So I can see that it actually does meet our deflection requirements, and 2 millimeters is a bit hard to see. So what you can do is you can use this exaggeration slider to check how the part would deflect and deform, if it will at all. And unfortunately, the minimum safety factor that we have of 2 wasn't quite reached, but the tool actually does tell us how much force it will withstand based on the minimum safety factor that the part is expected to be.
So we have an idea of how the current part as it is sliced now will perform. So what can we do now to adjust that part to make it stronger?
Yeah, so that'll actually be where our different optimization options come into play. So here, what the software has given us is the option for the fastest Onyx only print time for a part that will meet our conditions here. And then we also have a lowest cost Onyx only conditions as well. And these are actually going to be the same settings for this particular part. And then as we move further over here to the right, we actually have a carbon fiber reinforced version. And it actually prints 20% faster than even our original Onyx only version, and it deflects less at the same time as well. And then if we go over here to more options, we can see some more detailed results behind those configurations, such as print time, cost, and different layer heights.
Wow, so it looks like the software is automatically giving us options and choices based on what we think is important. So whether that be cost or time or strength. And so what actually happens when we choose one of these options?
Right, so once I've made my choice of what option I want, all I need to do is click on apply, and that will essentially reslice the part. And once the part is resliced, it'll be ready to print. And I'll switch over here to our final version with some carbon fiber included in it. And the cool thing about this optimization is you can do multiple different versions as well. And if you want to view a previous version, all you need to do is go over here to the versions tab and then click on either view or revert to a previous revision to see different results. So you don't need to import your file multiple times, run multiple simulations on it, have all of these different parts in your library. You can just run it once, and then if you want to go to a different revision and print that, you can. So this second revision right here is where I have my different simulation results that we just showed. So if I wanted, I could just look at that and look at those results really quickly and then load up another optimized version.
That's great. So one of the most common questions that I get from customers is, how do I know how much fiber to use? And so now we know the answer to that through predictive software based on their actual real world loading conditions. How cool is that?
Yeah, I'd say that's definitely one of the coolest things that I've seen in recent memory. So like you said, it's really been impossible to know exactly how much fiber to use in the past. And if you actually recall, when I first started out with this part, I didn't have any sort of fiber enabled. It was just an Onyx only part. So simulation gave me the choice to do an Onyx only variant if that was possible with the conditions that I set up. But it also gave me a carbon fiber inclusive version based on what my needs are with this part. And even things like wall thicknesses, different amounts of floor layers, different infills can be adjusted by the software. So it's really comprehensive in what it considers when performing a part study.
Thanks for showing us this demo, Jesse. This is awesome. So to recap, Markforged now has a simulation software embedded into Eiger that allows users to optimize part performance for real-world loading conditions. And then the software will make necessary changes for you in the slice settings automatically. Now, this software is free for a few months, so we want you guys to give it a try. And Jesse, for those new to Markforged 3D printing, what is the best way for them to start using this software?
Yeah, so like we were talking about, simulation is live right now. So all you need to do is activate it in Eiger or click the link down in the description to have it added to your account. And once you do have simulation enabled, it'll work on any new part upload. And if you have a part in your library that you want to simulate, all you need to do is reslice that part and it'll be ready to go. You don't even need to re-upload that part file.
All right, so we'll have a link in the description below, so be sure and check that out. And well, that's all that we have for you in this video. Thanks for watching, and be sure and stay in tune for other videos related to Markforged products and content. And with that, we'll see you next time.